Hello class, this is Mr. Lehman. Today I want to talk to you about Toxins Lesson 5. And it's all about balancing chemical equations. And so we learned before in Lesson 4 that in chemical reactions, mass is always conserved. So in a chemical reaction, matter is not destroyed and matter is not created. So therefore, if we have a chemical reaction involving different chemicals that are made up of elements and atoms of those elements, then through that chemical reaction, we're not destroying the atoms, we're not creating new atoms, we're simply rearranging the atoms that we already have. So today I want to work through the two questions in the homework packet. The first two they had to balance, letter A and letter B. And so on the next page here, let me go ahead and insert A and B here. So there's A. This is a pretty simple one. And so if you look here, we have K, which is potassium, solid. So we have solid potassium. Potassium's a metal. So really, it's potassium metal is reacting with iodine in the form of a solid. And together they're going to produce Ki, potassium iodide. Alright, so right now we want to take an inventory. So my starting point is I like to draw an arrow, or a line down through the arrow. That separates the left side, which I call my reactants, what I'm starting with, and on the right side I end up with my products. This is what I'm forming through the lab. Now, it's reactants are what you begin with, products are what you end with. My advice is to list the elements involved in the chemical reaction, list them in the same order on each side, and then tally how many you're starting with. So right now I'm starting out with 1 of my K. So if there's nothing in front of it, that's a number 1. So it's a coefficient of 1. It means I have 1 of these potassiums. And right now I'm starting out with 1 of these I's, but I is found in pairs, I2. So iodine is found naturally as a pair. And so I have 1 pair. On the right side, in potassium iodide, there's 1 K and 1 I. So you see right now this does not satisfy law of conservation of mass or matter, because right now an iodine is being destroyed and that cannot happen. So what I need to do is I need to figure out how many of each, the ratio of my reactions, ratio of my reactants to products, so I can satisfy the law of conservation of mass. So right now, if I need more iodines on the right side, if I need to end up with more of my products, what I can say is instead of producing 1 of these in my chemical reaction, I can produce 2 of them. So I can change the recipe. Just like if you're going to make pancakes and the normal pancake serving size is not enough for your family, you can double it or triple it or quadruple it. Here I'm choosing to double the recipe for this reaction. And so if you put a 2 in front, that means you have 2 of everything that follows in that chemical. So I have 1 K, but I had 2 of it now. So actually now I have 2 Ks. And I'm also doubling the amount of I's I have, so I now have 2 of each. So iodines, there's 2 of each, but now K's, I need to start out with 1 more than what I end up with. I'm ending up with 2, I'm only starting out with 1. And so what I can choose to do is I can say, hey, instead of starting out with 1 of these, I can start out with 2 of those. And so I double that part of it. Now notice over here, this is a separate chemical. So by putting a 2 here, I'm only affecting what immediately comes after it. I'm not affecting the second reactant here. And iodine, I just need 1 of it, so I can write a 1 here. I don't need to show the 1 here, but I can. So what I see here is I start out with 2 Ks, I end up with 2 Ks. I start out with 2 I's, I end up with 2 I's. Alright, so that's problem 1. I'm going to stop here. I'm going to start a new tutorial for problem 2, the more advanced one.